Let's see how to define the parameters related to the lateral buckling of bars in Strubium CYPE 3D. To do this, we open the bar menu at the top of the interface and click on Lateral Buckling. We select each one of the bars by clicking on them one by one or using the crossing method, and we confirm our selection with the right mouse button. In the pop-up window, we can define the lateral buckling parameters for the top flange and bottom flange of the section, as well as assign the critical moment factor by activating the corresponding checkboxes. The diagram above shows the positions of the top and bottom flange of the section according to the orientation of the local coordinate axes, which use the same colour coding as in the model. Among the options available in each flange, we find the following: does not check lateral buckling, beam fixed at both ends, simply supported bar, and cantilever bar. In these cases, the program establishes a predefined value for the lateral buckling coefficient of 0, 0.5, 1, and 2 respectively. By default, it does not consider lateral buckling. With the following button, we manually enter the lateral buckling coefficient by typing it into the field below. The result of this coefficient and the length of the bar from node to node equals the separation between bracing. We can also directly set the separation between bracing for each flange instead of using a coefficient. To do this, we select the corresponding icon and type in its value in the units of measurement defined in the project. We can also type in the equivalent uniform moment factor for each flange. Lastly, we type in the critical moment modification factor. Each code provides values for the equivalent moment coefficients and for the critical moment modification factor depending on the different bending moment distributions in the bars between bracing points. By default, the program uses coefficients that match the unit. Finally, we click Accept. When approaching the bars, the program shows us the values of the parameters applied to the two flanges and the critical moment factor value above them. We can also find this information in the box that appears when moving the mouse pointer over the bars in the lateral buckling section. If we have not assigned any lateral buckling to the bars in Analyze, the program issues a warning indicating this matter. If we continue, it automatically assumes the default values. Lateral buckling parameters have a marked incidence in some bar checks. The checks vary depending on the selected code, and we can consult them in the ULS checks reports in the Analysis menu. Among them, we can mention the Y-axis bending resistance checks.